The way Easter Island's iconic statues were built might completely change how we think about power, community, and lost civilizations. And this is where it gets really interesting. The latest evidence suggests those giant Moai weren't the product of one all-powerful ruler, but of many small, independent groups working on their own. Easter Island, also known as Rapa Nui, is world-famous for its massive stone figures called Moai, created roughly 800 years ago. These statues were carved from volcanic rock taken from a quarry called Rano Raraku, a dramatic landscape filled with partially finished figures and carving scars that tell the story of their creation. To understand that story in more detail, archaeologists have now built a high-resolution, interactive 3D model of the quarry, allowing anyone to virtually fly over the terrain and zoom in on tiny features that would be hard or impossible to see from the ground. A new picture of who built the Moai. The new study argues that the Moai were not produced under one centralized authority, like a single chief commanding the entire island, but instead by many small, decentralized work groups, most likely extended family clans. That conclusion comes from patterns in the 3D model that show clusters of activity and distinct carving styles in different areas of the quarry, rather than one uniform top-down system. In other words, the quarry looks less like a giant state-run factory and more like a patchwork of family workshops, each with its own methods and traditions. Co-author Carl Lipo, an archaeologist at Binghamton University and a leading expert on the Moai, emphasizes how powerful the digital model is for research and public access. From above, researchers can inspect the tops, sides, and hidden corners of statues, trenches, and rock faces that people can't easily reach on foot. Instead of relying only on field sketches and photos, they can now direct others to go look at specific details in the model, flying around the landscape to study carving techniques, tool marks, and subtle terrain features in a way that is comprehensive and easily shared. How the statues were moved. Lipo has also become well known for his experimental work on how the Moai were transported across the island, work that challenges older, more dramatic ideas of huge labor forces dragging statues on sleds or rollers. Using 3D physics modeling and field experiments with replica statues, his team showed that the Moai could be moved upright by teams using ropes to rock them side to side, almost as if they were walking forward. This fits with local oral traditions and helps explain how so many statues could be placed on platforms, spread across the island. Here's the surprising part. Earlier assumptions suggested that moving hundreds of giant statues would require tens of thousands of people living on the island at once. But Lipo's experiments indicate that far fewer workers were needed. His latest trials found that a team of just 18 people, 4 on each side rope and 10 on a rope at the back, could coordinate the walking motion well enough to move a statue 100 meters in about 40 minutes. For beginners, that's roughly the length of a football field in less than an hour, using nothing more than muscle, ropes, and a smart technique. The physics behind the walking method. The walking method relies on basic pendulum dynamics. When the statue is rocked rhythmically from side to side, its center of mass shifts in a way that reduces the friction at the base, making forward movement easier than you might expect for something so heavy. Because the system builds up a steady oscillation, the crew doesn't need to haul continuously with brute force. Instead, they nudge the statue at the right moments to keep it swinging and stepping forward. This is a practical use of resonance, essentially timing the pushes so that small efforts add up to big motions over time. In practical terms, that means a real Moai could likely be moved several kilometers over the course of a few weeks by a crew of perhaps 20 to 50 people. That is about the size of an extended family or small lineage group on Rapa Nui, rather than a massive, centralized labor army. Once a large group gets the statue rocking, maybe 15 to 60 people depending on how big and heavy it is, a much smaller, experienced team can maintain the motion, guiding and stabilizing it with relatively little extra energy, turning the quarry into a 3D time capsule. For the new paper, Lipo and colleagues carried out several low-altitude drone surveys over the Rano Raraku quarry between mid-2023 and early 2024. Flying at regular intervals and heights, they captured around 20,000 high-resolution images, carefully overlapping them so that software could stitch them into a detailed 3D reconstruction. For an archaeologist, Lipo describes the quarry as a kind of Disneyland. Almost everything about Moai construction is represented there in one landscape, yet, until now it had not been thoroughly documented at this level. The resulting model revealed a dense and complex archaeological record. The team identified 341 trenches outlining rectangular blocks in the bedrock, essentially the rough blanks from which statues would be carved. They also found 133 empty spaces where finished statues had already been removed, and at least 5 stone bollards likely used as anchoring points for lowering completed Moai down slopes. Another system of bollards appears to be linked to large bedrock pits, which would have made it easier to control statues moving down especially steep ground. Different carving styles, different groups? Most Moai seem to have been carved lying on their backs in a horizontal, supine position, with the statue emerging as carvers removed rock from above and around the outline. The 3D model helped the team distinguish 3 main quarrying approaches. In the most common method, carvers focused on the face first, shaping key facial features before refining the outline of the head and body. In the second approach, they completed the rectangular block shape and overall outline before adding detail features. A few rare examples show statues being carved sideways into nearly vertical cliff faces, a far riskier and more technically demanding strategy. These clear differences in carving procedures from one area to another are a big part of why the authors think the quarry was divided among separate workshops. Each zone looks like it had its own preferred sequence of steps, and possibly its own teaching tradition, which fits well with the idea of distinct family clans operating in parallel. When this is combined with the evidence that relatively small teams could move statues over long distances, it strengthens the view that each clan could plausibly manage the entire process, from quarrying to transport to installation, without needing a single island-wide organizer. A challenge to the Big Chief story. This interpretation naturally pushes back against the older, popular picture of Easter Island as a society ruled by a powerful chief who directed huge labor forces to carve and erect statues. In the new view, social power may have been more distributed, with clans expressing identity, status, and perhaps spiritual beliefs through their own Moai projects. That paints Rapa Nui not as a failed centralized state, but as a network of smaller communities capable of impressive engineering with limited numbers. Of course, not everyone in the field is fully convinced. Some archaeologists have reacted with cautious skepticism, agreeing that there probably was no single all-controlling chief, but questioning how isolated the clans really were in practice. They argue that on such a small island, where quality stone resources are limited and highly valued, cooperation and sharing between groups would have been essential. From that perspective, completely independent clan workshops might be an oversimplification, and there may have been more negotiation, alliances, and mutual support than the quarry patterns alone suggest. A debate that's just getting started. Archaeologist Dale Simpson, for example, has suggested that while the new model and experiments are valuable, they may underplay how much different groups had to coordinate with one another. If stone is the key resource and access is uneven, is it realistic to imagine clans working largely in isolation, each carving only for itself? Or does the evidence better fit a scenario where resources, labor, and know-how circulated through networks of exchange and collaboration, even without a single overarching ruler? That tension, between decentralization and interdependence, is at the heart of the current debate. There's also a broader, more provocative question